Hi, welcome to Python 3 programming course. As I told you, we have organized this Python course as three modules. This is the first module. Okay, this course is given by Subaraj Academy. We are in lesson 12, that is on functions. Understand that programming languages can be classified into two. One is procedure-oriented programming language. Second is object-oriented programming language. In fact, Python is both. It can be used as a procedure-oriented or object-oriented. So basically, the procedure and function are the same. You can even call Python as a function-oriented programming language. So functions are very important and very interesting too. Let us recall about structured programming. You remember that structured programming came to improve the quality of the program. In structured programming, what we do is we divide an application into a number of modules. Means what? Suppose you are developing an application for aircraft landing. You divide that into 10 or 15 different subtasks. And for each task, you develop program. Each one of them is called module. So structured programming means dividing an application program into a hierarchy of modules or autonomous elements or functions. Functions are autonomous, mean they are independent. Okay? Each function may in turn contain other elements, other such functions. A function may have called another function. And most important, in each function, we follow strictly the code is structured using blocks of related logic. We discussed about three programming constructs. Sequence, okay, iteration, and the branching. So under each function, each code is structured to result in good quality of program. And structured programming is to improve the reliability and maintainability. What is maintainability? Means suppose something goes wrong, you want to repair the system, you can do it easily. How much time it takes to maintain or repair a software is a measure of maintainability. So you should design the program. It's very complex matter, complicated matter. So you have to have a lot of care. You have to give a lot of care while designing a software system. There are two approaches to programming. One is top-down approach, other is bottom-up approach. The top-down approach, you design the whole thing. Okay? The topmost model, it calls various other models. So we don't implement the other models right away. We only design the system, such a manner what the system consists, what are the various major functions to be accomplished, and so on. So in top-down approach, you start from the top. And the bottom-up approach is start from the bottom. Anyway, we will the top-down approach is recommended. It involves designing the overall program structure, followed by designing individual functions. So, if you are doing whether top-down or bottom-up, you have to have functions. Each function is called a separate module, independent. They're tested individually, and later on they're integrated with the other modules. Okay. The function should be designed in such a manner that it has one entry point and one exit point for each function. There are two types of functions. One is library functions, and the other is user-defined functions. What is the library function? We have seen a number of library functions like print, eval, input, isalpha, isupper, format, sort. All these are mathematical functions. And there are other functions also, mathematical functions, the non-mathematical functions. Also, the print is not a mathematical function. eval is also not a mathematical function. Okay, and we also have main function in Python. Every language has a main function. I know of C, C++, Java, everywhere is a main function. So Python also has a main function. It's a function. What function? A group of statements. Okay, linked together. So far we wrote programs, but we didn't specify any main function. But it worked well. Although we didn't specify, the main function was present invisibly. Okay, the main function is there in every Python program, and the main is the place from where the program starts execution. What are user-defined functions? These functions are defined by each user to suit his own convenience. In designing such functions, you may also use library functions. You write the program in such a manner that the main function calls other functions as needed for carrying out specific tasks. So you start from the main function. Okay, I can draw a diagram. So you start with the main function. Here you have number of, it calls number of other functions. Okay. The other functions are here. So the main calls different functions for performing different tasks. Okay. This function may call another function also. This function may call another function. That function may call another function. It's endless. Okay. Let us take an example of a function. Here we want to find the sum of two numbers. So we can divide it into two parts. See, divide and conquer is one of the recommended strategies for program design and development. So we divide it into two parts. One is the finding the function sum. Let us start from the top. The main function what you could do is define function sum. You define there is a function sum, but don't implement it. And then get two numbers from the users, 2 or 3, whatever number you want. The call the function sum and pass the two values. Get the sum from the function sum and print the value of sum. These are the tasks of main function. The specialized task is addition. That is done by the function sum. It gets the value from the main function, adds them, and return the value to the main function. So this way you can partition the task. Two parts, basically, here you see what is above is one function, what is below is another function. And both can be coded independently, but they are dependent on each other. So there is the format for everything. So here is the general form of function. There are two parts of a function in Python, like any other language. The function definition and function call. Okay, two important function definition and function call. And function definition in turn consists of two parts: function header and function body. Okay, what is function definition? Function call. Function definition has two parts. Okay, the function header starts with the keyword def. Def. Any function name will be preceded by def. It is followed by the function name, can be main function or any other function. Diff, add. The programmer can choose whatever name he wants, and he lists the parameters. Means we'll clear very soon. In parentheses, and it's separated by a colon. See, colon very important in Python. The example given: def sum is the name of the function. Num1, num2 are the parameters or arguments or values we pass it to the function sum. I told you the sum gets two numbers. So that is represented as num1 and num2. The function body is where we put the code. In the body, what we'll say? We will create one more variable, say var1, and var1 is equal to num1 plus num2. Return var1. That's what we will write in the sum. Look at the program. So first we code the function sum, diff sum, num1, num2. It gets two values. See, the beauty of Python is you don't have to bother about what is the data type. This is the function header. This is the body. The other two lines of body is a total is equal to num1 plus num2. Num1 and num2 are received from the main function and return total. This is all the function sum. Then we have the main function which calls the function. The called function this is the calling function. This main same format colon. You get a value A from the user, get a value B from the user. Then you could assert that sum is something. You have to call the function. You could have put sum A B, but here we are combining that with the print statement. Print sum of two numbers. This is the string, comma sum A plus B. So this sum A plus B we call the function sum and pass on the values A and B, and that will return total. That will be printed. See, here is the main, and this main and main. This is the place from where the program execution starts. We can call a function multiple times, not once, any number of times. That's the advantage. You code a function and call it as many times as you want. So you save efforts, you improve quality. This is the program, this is the commands, these are the commands in the call function. Okay, we are defining sum as the function with receiving two arguments, and total is found and return total. This we already seen. Again, calling function A and B, we already saw. This is sum1 is equal to sum A B, A comma B. Means sum1 will be, it calls the sum function and adds two numbers, and it will return sum1. Okay. Then C, now then we get another value C from the user, and D another value from the user. Sum2 is equal to sum C comma D. Earlier sum A comma B, then sum2 is C comma D. There are two sum1s, there is sum1, sum2. Now we pass, we print sum of numbers C and D is sum2. Now we call one more sum where we pass sum1 and sum2. So we are calling the function sum 3 times. We can call it any number of times. If name is equal to main, this is another way of writing, the right way of writing. I'll explain you the reason just now. So the program execution starts from main function. In the future program, we may be importing other programs called modules. They also may have main. However, the name of the import modules will not be main. What we want to do is, we want to start execution from the main function of this module. So when the program executor runtime environment notes the definition of function main, when it parses the if statement, it checks the name of the module being executed. If it is main, then it calls the main function in the current module being executed. The purpose of the last two statements is to ensure that main function in the current module is executed and not from the imported models. It will be very clear when it is formed. Now, I'm defining a problem. Okay, the user gives four-digit number, and I'm going to do, if the number is odd, then the number has to be a reverse. You know what is odd? 21 is odd. If it is even, then the number has to be doubled. If it is evenly divisible by 3, then the digits are to be added. Suppose it's 21. What will you do? The odd number, so the number will reverse from 21 to 12. And also, it is divisible by 3, means the remainder is 0. So add the digits 2 plus 1 is 3. Suppose it's 22, you will only double it to 44. So what is the algorithm? Get the number. The number is odd, we call the reverse function, means you will have a function called reverse. Else multiply the number by 2, and hence call multiply. The number is evenly divisible by 3, called add digits. So we are going to code three functions. The first function we are coding is reverse. So let me explain with an example how this function reverse works. Suppose the number is chosen is 21. Okay. So initially rev is equal to 0. Initially rev is equal to 0. My number is greater than 0. Number is 21. It's definitely greater than 0. Rev is equal to rev star 10. Rev is 0 into 10 is 0. Plus num percentage 10. Num percentage 10 is 21 by 10, which is 1. The num is integer division number by 10. That is 2. 21 by 10 is 2. Number is 2. Number is greater than 0. So rev is equal to rev star 10. What is rev? Rev was 1. That is 1 into 10, 1 into 10, 10 plus number percentage 10, which is the remainder of 2. When you divide 2 by 10, the remainder is 2. So 12. So 21 has been reversed to 12. Okay. This is the reverse function. Function is multiply, that is simple. The number is received and you double the number, 2 into number. This is an interesting function, add digits. Okay. So add digits, you get the number. In his sum is equal to 0. While number is greater than 0, sum is equal to sum plus number percentage 10, that is modulus 10. Say suppose the number is 22, 20, let's say 24. So sum is 0, 0 plus 24 is, the remainder is 4. So 4. Okay. The number is, this will be, it will be 4. So sum will be 4. So number by 10, 24 divided by 10 will be 2. 2 is greater than 0. Sum will be 2 plus, sum will be, it was 4 plus 2, it will be 6. Try to do it yourself. So in the call function, we receive the number. Type whatever number you want to type. If number is odd, reverse the type numbers. If it is 355, okay, it's an odd number, so it will be 553. If it is 356, multiply by 2. Then if it is divisible by 3, then print the sum of digits, add digits. So we call all three functions in one main function. There is something called void function. If you look at the multiply function, we didn't return anything. The other two functions, we were returning something. Okay. So the function without an explicit return statement is called a void function. If the function doesn't return anything explicitly, okay, specifically, then it's a void function. Then how the control goes back to the main function? It's because the void function returns a special value called none to the called function. Okay, returning sum is okay. But if we don't return anything, a none goes to the called function main. So that facilitates the return of the main function in the above situation. Let's do another program to find the difference between 2 points in mathematical, simple mathematics. If list x1, y1, x2, y2. This is a coordinate. x1, y1 is one coordinate, x2, y2 is another coordinate. Result is x2 minus x1 whole square, y2 minus y2 minus y1 whole square. The whole thing we take a square root, 0.5 times, square root is 0.5 to the power 0.5. If you take that, you get the distance. So, print distance between x1, y1 and y2, y2 is result. So, main function x1 in enter numbers x1, coordinate x1, coordinate y1, points of 3, 4. x2, y2 maybe say 7, 8. Then distance you call the distance function, passing x1, y1, x2, y2, and you get the result. Let us now write a program to find square root of a number. You know about mathematical functions. There is a function called sqrt. So that will straight away give you what is the value of the square root of a given number. Suppose The square root of 25 you want to find out. X will be 25. So it will put math.sqrt will be 5. Here you have to import mathematics. You can also do it without importing math library, which you will see in the next slide. We will now write a program to find the square root without using the mathematical function. Maybe I'm apprehensive that math function may be slow. Maybe, I don't know. So in this program, I call to distinguish between that mathematical function small sqrt. I have uppercase letter S here to denote the function. So in the main function, we get the value number to which you want to find the square root and call that through indirectly through print sqrtx. So sqrtx is this function. This is a called function, the calling function. So in the function, what we do is last guess is equal to x by 2.0, the float division. Let x be, that is the number for which you want to find the square, be 16. So this will be 8. X by 2 will be 8.0. While true, guess is equal to last guess. Last guess is 8.0 plus x 16 by last guess by 2. That is x by last guess, that is 16 by 8, that is 2. So 8 plus 2 is 10, by 2 is 5. So the guess will be 5. What was the last guess? Was 8. So if the value, what is the difference between these two? Absolute value is 3. So you cannot stop. So now what you do is last guess is equal to guess. What is the guess now? Guess was 5. So the the last guess will be 5. Go back. 5 plus and so on. Do this. So when the difference between the last guess and the guess is very small, then you return guess. Okay. So this way you can find out the square root from first principles. You must carry out assignment 1.4 at the end of the lesson. And before that, you practice the programs I taught you in this lesson and complete assignment 1.4. Unless you complete 1.4, you can't go further. Okay? That's all for now. Thank you for watching. Until we meet again, bye bye.